Equation of 2D equilibrium. So we now know how to draw the Fibor diagram. Remember, if you want to do analysis only at any one point, you draw that point and cut it off from the surrounding and apply all the forces and known information on that point. And then you apply your equation of equilibrium. Just to summarize the equation of equilibrium, now this here in this example, they are taking point A and drawing its Fibor diagram, which is given here. That's your Fibor diagram of point A. And on all the forces, you apply equation of equilibrium. Sum of all the forces equals 0. You can see that. So that's the vector force force AB. That's this one. You got AD. That's this one. And you got AC. That's this one. So sum of all the forces along X equals 0, and sum of all the forces along Y equals 0. I'm not going to go into the details. You already know this. We've covered it already. Okay, so once we know the engine weight, that's given here. And we do sum of all the force along x-axis. Along x-axis, we've got this component and the component of this force. So both are in the opposite direction. So you got a negative sign here. You got the negative sign. So that's in the negative direction. You can see that. And this one is in the positive direction that you can see here. So that's sum of all the force along x-axis. Then we see sum of all the force along y-axis. So we got component this one, which is downward. So definitely negative. Therefore, you got a negative sign. And the component of this vector here is upward. So it's positive. So this component is here. So sum of all the force along x, sum of all the force along y. How many unknowns we've got? We've got this unknown and this unknown here. Two equations, two unknowns. You calculate it, you get your answers out. Is that clear?